recording and transcribing, so it looks like it's working.
Yeah.
And I guess Sam or whomever can just edit this afterwards. So, all right. So I guess just waiting for Aymaan at this point.
Yes.
Okay.
All right. Yeah. Getting off the hotel network seems to have helped a little bit. I think Google Fi can be our savior. LiveJO. Looks stupid. I don't know which angle I use, but
I think I've got my thing.
yeah.
Ready.
So his question was also.
So yeah, should I start? I mean, I can probably be pretty quick, I guess.
If you'd like to, yes.
I think I just added one or two more slides. I don't think I have like a ton really. And then, I think he can go after me because I think his is a more, I'll say, deep dive.
I'll do a quick intro, which will be like a minute of both you guys, and then you take it away.
Okay, sounds good. Maybe I will get some water before we start. I'll be back.
Always a good idea. Why is that so? Worse. Okay, all right. Get a little more light on the subject here. So I also gave you access to the Luventix meeting if you want to.
Okay, sure. Yeah, I might hang out in that for a bit. Maybe not the whole thing, but thank you.
Huh.
Hey, Aymaan, how's it going?
Pretty good. How are you?
Doing well, thank you.
Aymaan, thank you. Thanks for being here. As I was just telling LeRoy, I will do a quick intro, and obviously we'll edit this afterwards. And then feel free to go ahead. Or actually, I think he's going to go first and then introduce you. So I introduce you both, then LeRoy says a few things, and then introduces you. Is that's the way we want to do it?
Sound good? Because I think mine's gonna be brief. Mine's just gonna be more kind of like a brief overview, kind of what I've done. But I can just throw it to you because yours is, I'll say, more of a deep dive into things. So sound good?
Yeah, and I should leave some time at the end for like Q&A, I guess.
Right. Yeah.
Okay.
So yeah, I'm gonna be pretty quick, I think. So.
Okay.
Well, yeah, I have an angelic glow behind me, so I'm feeling good. Okay. So for Sam, we'll do a countdown.
Okay.
I'll remove my gum. Okay. 3, 2, 1. Hello, everyone. This is Jim Collins from Excelsior Capital Partners. This is the latest edition of the Rising Series podcast. With us today, we have two experts on the field of artificial intelligence, which is obviously very much on everybody's minds in the markets these days. So we have LeRoy Wong, my old friend and college buddy, and also an educator at Burlington High School, Burlington, Mass., and one of his former students, Aymaan Shaikh, who is working now in the AI field. So with that, I will send it over to LeRoy, and he can educate us on this very interesting topic that I know nothing about.
Great. Thank you very much, Jim. We appreciate the opportunity. So I'll just go ahead and start presenting my screen here. Give me 1 second here. Okay, so hopefully folks can see that. As Jim mentioned, my name's LeRoy Wong, and I work at Burlington High School, and just going to give a brief overview of the AI work that we've done at Burlington High. So this is my LinkedIn profile. I'm probably not going to click on most of these links, but this is something that Jim can share later, I think, on his channel, if you want to go back and look at these slides.
Yes.
But I'm a technology teacher, and I teach technology exploration, which I guess is started as sort of like a student help desk program where the students are kind of like the Genius Bar or tech support for the school. I also teach intro to game designs, that's video game design, and then exploring computer science, which is like a kind of intro computer science course. I also do esports, so we actually have that as something at our high school. And then I'm the programming club advisor, and then later you're going to hear from Aymaan, who was the leader of that programming club at the high school when he was at Burlington. A couple of other articles that I have here, if you're interested. We have been profiled in the International Society for Technology and Education website, and there's also an AI story when we had kind of first started doing AI. So I do want to give a disclaimer. I'm talking a lot about Burlington, kind of things we've done with AI, but I just want to say the opinions that I'm expressing in this video or this video conference are pretty much my own. Just don't want to get into any sort of trouble, which I don't think would happen, but safe side. I don't want to. So what are some of the things we've done with AI in our program? So I'd say 2018 is when we really started doing stuff with chatbots. So this was several years before ChatGPT kind of exploded onto the scene. Chatbots definitely existed, but we were fortunate enough to be selected to present at this ISTE conference, the International Society for Technology and Education Conference on chatbots. So what we used was something called Lex. So this is just the interface here, and it was within Amazon Web Services cloud platform. So we learned a lot from that, and it was interesting to just kind of understand, like, well, how do you make a chatbot? By this time, I think most people were using Siri and Alexa and things like that. So it was interesting to just sort of dive a little bit deeper and understand, like, well, what is it? What's the actual tool, or what are the tools that are used to make chatbots? So that was a really great experience for us to do that. Fast forward to, I guess, really the past couple of years, ChatGPT, as I said, has kind of exploded onto the scene. It's something that's now being used by a lot of different folks. And we've done things with like image generation as well. So a lot of companies, as you know, are doing their own kind of AI type integration into their products.
Oh, yeah.
So Adobe has something called Firefly, where you can just put in a prompt. So I don't remember my exact prompt for this, but it was like, you know, students working in a futuristic classroom. And so within 10 or 15 seconds, it will just generate an image like that. So those are some of the things that, you know, you can do with AI that within really the past few years, like the abilities have been pretty impressive. Image recognition is something else that we've done. So we use kind of a website called Teachable Machine. That's just like a short video that shows you that if you have your camera or your microphone on and you're kind of capturing samples of different images or sounds, it shows you how it's very easy to kind of like make your own sort of AI tool. And so if you're interested in that, you can go to that Teachable Machine site. It's something that I usually show in my classes as a very simple way to kind of do AI. Pi image search is something that we use. So in the realm of like self-driving cars and whatnot, definitely like a very important component in trying to understand, like, well, how do computers see images and classify them so that if a car is driving, how does it know that there's a pedestrian, or traffic signs or signals, other cars, lines, and things like that. And oh, interesting enough, my Siri was activating. I don't know why. And oh, I'm not sure why it's not going to the next slide. There we go. Other things we've looked at.
Sorry to interrupt.
Yeah, sure.
LeRoy, but just to go back to, because some of this is over my head already, which was bound to happen. But a site like Teachable Machines,
yes,
and this is an investing conference, so is that sort of a corporate venture, or is that kind of
yeah, so it's basically like a Google educational site. Yeah, so essentially, like when you go on to Teachable Machine, what happens is you just kind of go on, and then let me just go back to the other slide real quick. And so, like in this first very short clip, there's a young woman that takes a whole bunch of pictures of herself without the stuffed animal, or like in this case, the young woman with the guitar. She'll be playing a song on a guitar with distortion and without distortion. And so it's just a very quick way to demonstrate like how you feed a computer samples of images or sounds, and then through the algorithms it understands like, oh, so this is a picture of me, this is a picture of me with a dog. And that's just a really simple example. And so it's really more of an educational site that Google created, but definitely something that folks can kind of look at later. And it's just kind of like a fun, easy way to demonstrate how AI works.
Is there something that, sorry, interrupting again, but
not a problem.
And because of BHS and Massachusetts regulations, whatnot, are there times when you have to use open source programs like ChatGPT, which I don't completely open source, obviously, but what Microsoft paid for a stake in OpenAI, but are there times that you have to use open source versus things that are controlled by Google or Microsoft?
That's a very good question. I'm actually glad you brought that up. So, one of the issues with, I mean, not just with AI, but anything that a school would use that's online is student privacy and data privacy. So, I guess I'll speak specifically to ChatGPT. We haven't blocked it, but a lot of districts have blocked it. Maybe not even so much for the privacy issue, but more for the cheating issue, which we can talk about a little bit later, time permitting. So I think essentially, there are concerns around that. And so while we don't really endorse it, so to speak, it's not something that we have blocked, but certain districts have. So at this point, there's so many different tools being developed. Again, just in general, I mean, definitely in education, but just widely in technology and other industries. So essentially, there are going to be concerns about privacy. Obviously, the cheating concern is probably the biggest one right now. So I think we're a little bit more forward thinking in our district, in that we don't kind of fear these things and think like, okay, we got to shut this down, because obviously most students have phones and access to the internet, and they know about these tools and they're using them, I think for good things and not so good things. But at this point, we don't have a very clear policy, but a lot of districts are trying to work on that, seeing as how AI is being used so much across the board, if that makes sense. So
yeah, it does. Thank you. Sorry to interrupt.
Yeah, not a problem. So yeah, just have a few other slides. So other things we've looked at are just AI biases, scams, deepfakes. So you've probably heard about these things in the news. Facial recognition software, while amazing, I think in the earlier days of using it, and earlier days I mean a few years ago, really. Essentially, the models were developed with primarily white faces. So there was a graduate student at MIT who wanted to learn more about facial recognition software, and she found that when she held up when she had the software try to recognize her as a Black woman, it didn't. And then she would hold up a white mask, and suddenly she realized, like, oh, like it really only recognizes you if you have white skin. So she kind of delved a little bit deeper
Wow.
and found that the models had not really been trained with enough comprehensive images of people of different races, et cetera. So, we learned about things like that. There was a 60-minute story on cyber scammers. So voices can be copied. People's faces can be sort of copied and then manipulated. And so, those are things that are being used now to scam people. And so there's an interesting 60-minute story on that. I put deep face. I'll fix that later. I meant deep fakes. So essentially, those are videos that you may have seen where you'll have a celebrity or a politician saying something that they definitely didn't say. So there's also that concern about any sort of political misinformation and things like that come about. So those are just kind of other topics that we've explored in my class. So I'll just quickly say my general feelings. I think it has incredible potential for helping people learn and create things. It can be dangerous if students just use it to cut and paste and cheat. People still need to see what AI is producing because there can be something called AI hallucinations where AI will just kind of come up with stuff that's not true. So ChatGPT will do that sometimes. And then I guess the thing that is also very unusual is that some programmers are actually really, even most or all programmers don't fully understand that AI will do things. And certainly it's coded, but I think since the machine is kind of teaching itself, it's really hard to untangle that and figure out like, well, why did we get the output that we did? And so that's another interesting thing about it, and that it's a creation that has become something that feels human-like or approaches that. So I think humans are unpredictable, and I think the machines or the algorithms have kind of become that as well. So in general, I think if we teach people to use AI responsibly and make sure we're checking what it's producing, it can be a major benefit. And I think users and companies that develop it just need to be ethical and transparent with whatever they do with AI. So I think that was my last slide with content. Actually, there's one other. I do have some various AI links that you can click on. So it's other articles and videos I think might be of interest, but it was a lot, so I put them in a separate Google Doc. And then finally, that is my contact info. So I don't know if there are other quick questions, I guess, before I throw it to Aymaan with his presentation.
No, please. Let's hear what Aymaan has to say. But thank you very much. That was
you're welcome. Okay, so that was like I said,
very informative and actually a little bit scary. And I knew I would be scared today. It's just a matter of the degree of scared. But that was kind of scary.
Certainly. Okay, so I'll stop my presentation and then I'll go ahead and throw it to Aymaan. So he was a former student of mine, graduate of Burlington High School, and he has a presentation that's going to go a little bit more in depth into what AI is and kind of the work that he's been doing with it. All right.
Yeah. Let me see. Can you guys see my screen?
Yes, definitely.
Yes.
Okay, cool. Yeah, so let me just get started. So I'll basically give just like a quick intro of who I am, just my background, and then I'll talk a little bit about AI as a whole and just some of my experiences in AI. So let me start. So my name is Aymaan. I'm currently a senior studying computer science at the University of Massachusetts Amherst. And let me just go straight into my background. So I am currently a AI and ML engineering intern at Verizon, and I'm also a machine learning researcher at Dartmouth College, and I'm a Microsoft ambassador, student ambassador. And at UMass Amherst, I'm currently working in 2 labs as a machine learning researcher and natural language processing researcher. In my past, I've worked at Fidelity Investments for the past 2 summers as a full stack software engineering intern. And I've done some research at the MIT IBM Watson AI Lab in Cambridge as a machine learning researcher as well. And some other things I've done is I've worked at a few startups, including Super AI, and their company focuses on creating personality engines. So one of their products is, for example, if you're a celebrity, they kind of take your data. So they take your social media, all information, and they kind of generate a chatbot using your own personality. It's kind of scary, but that's one of the things that startups are starting to do. So I kind of got to help work on their personality engine. And I've also worked as an iOS developer for a startup called Top Closet, where you basically just sold clothes. And I was part of an AI fellowship at the R42 group. So they're basically a Stanford-backed venture capitalist firm where they kind of invest in just any sort of AI companies, ranging from healthcare to just cutting-edge AI. So
that's very impressive. Oh, thank you, Aymaan. That's sorry to interrupt, but your background at such a young age is making me think I wasted a lot of my life. But anyway, sorry.
Thank you. Yeah, so let me just start by just talking about a little bit of what is artificial intelligence. And just a quick disclaimer, like whatever I say, just like Mr. Wong, it's my own opinion and not just associating with all the other companies that I'm currently working at or have worked at. So artificial intelligence or AI is just the technology that enables computers and machines to stimulate human intelligence and problem-solving capabilities. So let's just go into what all this hype is about. So the rising speed of just the technological adoption of AI itself is just really crazy. I think everyone's just starting to talk about generative AI, and we haven't exactly seen a similar media phenomenon since like just the birth of like social networks or smartphones, and even before with the birth of the internet. All of those booms have had like a common factor, and that's just the fact that it's had the power to just revolutionize our society. And I think that today that the majority of people on the globe have access to the internet, and the speed that AI itself is progressing and just the access to that news is continually getting greater and more users kind of getting on it. And that's just kind of allowing for a greater rise in adoption. And as you can see in this graph, that just like as a whole, AI itself is growing a lot faster than what all of these technologies have done in the past. So we can see like for technology adoptions born after the year like 2005, so social media, smartphones, and tablets. Even looking at more recent technologies invented in the last decade, like the internet and the microcomputer, the adoption curves are way more gentle and less steep than today. And we can kind of see how generative AI, like just the speed of adoption is probably the highest we've ever seen. So just like a quick history, to understand like what's changed and what the hype is about, we can do like a really quick step back and just define some type of pre-learnings about AI and natural language processing. So if we enlarge like the time window, we can observe how things weren't always so fast. So some of the first projects in the AI domain kind of date back to the 60s, when some of the first researchers began to explore the possibilities of just creating machines that can replicate some of the human cognitive capabilities, like conversation. So initially, symbolic reasoning was just like a prevalent approach, and that kind of led to a number of important successes. So one of the first ones was Eliza, like the first written chatbot that was kind of acting as a psychiatrist. But it kind of soon became clear that such an approach doesn't scale well, and extracting the knowledge from an expert and then representing it in a computer is a really complex task, and it's pretty expensive. So this kind of led to an AI winter in the 1970s. And that kind of led to a turning point that arrived in the 90s with just like the technological evolution, where it basically allowed for cheaper and more capable abilities to handle large amounts of data. So together with the creation of new algorithms that was classified as machine learning, which was just the ability to learn patterns from data without being explicitly programmed with specific instructions. So these new sort of statistical models called neural networks that were kind of inspired by just the structure of the brain as a whole. So they're kind of made of interconnected neurons that, similar to a brain, gave boost to AI research development, and that just allowed for the ability to work with more complex inputs, not only categories or numbers like image and audio. So these statistical models kind of belong to a subgroup called machine learning, or even called to deep learning, which kind of just with the elaboration of better and more powerful GPUs or graphic processing units kind of led to a bigger boom. And that kind of pushed towards modern virtual assistants, just like Siri, Cortana, and Google Assistant. And those are all built upon language models that are based on neural networks.
Okay.
So these are pretty proficient in the subdomain of AI, which is just natural language processing, which is the capability of a machine processing and interpreting the human language. So generative AI is kind of like the cutting edge technology in the field nowadays, and it's able to generate examples starting with a huge amount of data used to train the model. And when I say huge, it's like all the data that's publicly accessible on the internet. So that's why when we talk about large language models, it's because of just like the sheer amount and volume of the data that's used in their training. And because of the number of small and large calculations they're able to handle at the same time. The example those models are able to create could be different types. So we'll see it in more details, but from text to code and images. And as you can see in the image, like the output of the large language model is asking if it can write some poetry.
Wow.
So let's just talk about a little bit of the progression. So first of all, let me say that we're talking about statistical models. So it can be intuitive as those models work better with numbers more than words. So the first challenge to face is how to convert words into numbers. So there are kind of three fundamental steps. So the first one, starting from text, is to just split it into smaller pieces known as tokens. So a token has a dimension that can vary from one another, but to make things simple, we will just be using the term token like interchangeably. So once the text is split into tokens, we can build a dictionary so that every word is just mapped with a number. And there are a ton of different algorithms that kind of do this kind of embedding. And a popular one is called a bag of words. And you can kind of take those mappings by taking into account the standard size of a vector. So in this example, we can set a dimension to 10. So that means you're just building an array of 10 numbers and collecting those numbers mapped to the tokens. And then the rest of the array is just populated using like a placeholder, like 0. So once the text has been converted to that array, you can use that input for the training of a neural network. So the way this works in simple terms is that each node making up the network is kind of activated by some kind of activation function. And you kind of take the sum of the inputs of the neuron, and the output node is just like the input following one. So that's kind of like forward propagation. And it kind of gets a lot more complicated, but there's just all these hidden computations that happen. And that's kind of where all those hidden layers and all those, the depth of the layers and the amount of computation, that kind of defines how deep the network goes. So from this training process, you can kind of get a dimension of 10 where the tokens of the input text are grouped into clusters of similarities. And the words with similar meanings are the closest one to another in this like semantic space. So in this deck, you can see the resulting space represented as a 2-dimensional space, since it's just the most intuitive way for us to represent and understand the reality.
Yes.
So it's kind of easy to grasp as representing words in a semantic space. So I guess it's not enough to just represent the whole meaning of a sentence or a text. And the reason is that context matters. So the same word can have a different meaning depending on the context. So if we just take an example in the English language, so she had coffee versus she had strength. The term had has very different meanings in the two sentences.
Yes.
And it's true in Italian, for example, that you would use two different words, but to be able to tell that the two terms had like a different meaning than two sentences based on the context. So you kind of have to convert the words into ideas. So those are kind of represented in the semantic space as two different items. And that semantic proximity is kind of computed on the idea that you're taking that account into context. And that's kind of how the neural networks that are used in the NLP domain work. They process a collection of words into a linear window, and you're kind of shifting through the text as the model reads it and analyzes it. And once you kind of encoded the collection of words into a complex idea in that space, you can decode it and you can kind of get the desired output, which kind of varies from the domain and application you're going for. And then you can kind of go from there.
Yeah,
And
that's amazing.
convolutional
If I
neural,
could jump in here. Sorry, Aymaan. I'm actually in Italy now, in Milan, and
oh, cool.
if I had, I took an Uber ride today, which really put me in fear of my life more than one time. So if I had had something like this, I mean, obviously I have Google Translate on my phone, everyone does, but if I had some way of just, convincing this person to drive more safely, um, it would have been amazing. But I'm just wondering, sort of, when it feels like something like Google Translate is which is amazing, is two-dimensional. So what you're saying makes me think that there's almost a way to get that into almost a third dimension of understanding and idea generation that is more than just making the words right and put them in the right order, which is difficult. Do you think that's possible? And do you think that's something that people are working on today, or I'm just talking out of my head?
Yeah. Yeah, so there are a lot of different companies and I guess like models that can work on that. So it's just like the way you use the data representation. So if you have like 3D coordinates in a 3D space and I guess the way you set up those neural networks. So to solve that simple thing from 2D to 3D, there are 3D convolutional neural networks that just extend 2D by adding another layer of depth. So that's exactly what you're talking about.
Sure. I mean, I think that communication, as I travel a lot in different countries where I never speak the language well, is so much more than just words. So that's something where I think neural networks could obviously help, because it's just the speed of it is just remarkable.
Yeah, no, definitely.
But sorry to interrupt. Please continue.
Yeah. So I guess like at this point, you can kind of see that if we have this sentence and we wish our model to just answer this question, why didn't Mary accept the coffee? To answer this question, I guess our model should be able to just correlate the expression didn't accept the copy with she, and then she with Mary. So that kind of covers this long window of words. And I guess the greater the dimension of the window, the greater the complexity of the model and the cost of its training and the probability of its error. So these recurrent neural networks are based on these windows of words, and the encoder's parameters can be kind of as smart as a sequence at C is. So like the cost of training can definitely vary depending on how big and how much data you're using, and I guess just like the complexity itself. So this invention, just kind of enabling the revolution in deep neural networks, has kind of been like the mechanism of attention. So that's kind of just, again, inspired by the brain itself, and it kind of gives a different weight to the input we receive. So we can kind of focus, for example, like voices that are speaking to us and kind of isolated from a noisy background, similar to this basic idea of a deep network attention mechanism. So each time the model tries to predict an output word, it only uses parts of an input where the most relevant information is concentrated instead of using like that entire sentence. So a new neural network architecture has kind of been built upon this attention mechanism. So that's called the transformer. And this architecture uses multi-head attention. So that kind of combines these multiple heads, and in a way that the model can kind of attend to different parts of the input sequences, where it can simultaneously analyze multiple possible combination of words. And this kind of allows you to overcome the linear and fixed size window of words of the recurrent neural networks. So that kind of allows deep networks to learn the semantic meaning without proximity. And this kind of transformer architecture is always made up of an encoder and a decoder in the example. So in the example of the translation, the encoder has the input sentence to translate, while the encoder has an input that's the hidden state. So that means the part of the sentence that has already been translated, and the output of the decoder is translated as a token chosen from a list of words and the next token. So in the case of recent LLMs like GPT-3, it's not always the token with the highest probability, but there's a degree of randomness added in this choice so that the model isn't purely deterministic. So it doesn't always have the same output for the same input. And this kind of randomness is added to just simulate the process of creative thinking. And it can kind of be tuned using a parameter called temperature. So that kind of lets you have the degree of randomness. So that's kind of where the term transformer stands from. So I guess like for GPT itself, like the generation of models include models trained with a lot of unsupervised data from various sources. And you can kind of tune these specific tasks, like for ChatGPT, which has been built on GPT 3.5. And that's kind of been fine-tuned for conversational domains, or Instruct GPT, which is optimized to execute user instructions written in NLP. So you can kind of observe the progression throughout the years from the very first GPT model, GPT-1, that was born in 2018, trained with hundreds of millions of parameters, up to the current new GPT-4, which is much larger, trained on hundreds of trillions of parameters. So that's almost 500 times bigger than GPT-3.
Wow.
So the size of parameters just increased more and more from one version to the next. So that kind of just results in better performance and efficiency. So in simple terms, the more parameters means more knowledge and just a better model. But the size of the model is not the only criteria to consider. It also varies on the different domains or modalities that can handle its capacity. So GPT-4 kind of demonstrates a high level of proficiency, not only in conversation or literature, but also mathematics, music, medicine, and it accepts both text and visuals as inputs. So also those models have kind of evolved and just been used by more and more users, and they're analyzing the prompts and those corresponding behaviors to just refine the model and the generation of the test. And they're kind of mitigating the risk of unsafe and undesired outputs. But all these model generations kind of share the same operating principle, where being pre-trained models on a huge corpus of data, they're just able to apply the knowledge on tasks they were not explicitly trained for. So if you have a prompt that is generally a natural language input, according to the different use cases, it can simply contain the sentence to complete. And for the completion, it's the model output that's kind of generated from the given prompt. And the output is generated one token of time just based on the probability of completing its text. And the token is just like the smallest unit in which the language model spit text to process it. And like another concept that kind of comes to mind is just, you may have heard of it, but it's prompt engineering. That's kind of like the accurate design of a prompt to just optimize and customize the output for our needs. So I know Microsoft and OpenAI have a very public partnership where they're kind of just trying to build systems that build general intelligence. So that's a real shift in what can be done with machine learning. And they partnered about 4 years ago, and GPT-4 is currently using Azure for building those specialized hardware. And so you can see that there's a bunch of different types of these technologies. So GPT-3 for they can understand and generate text, providing a prompt. So these models will generate an answer with natural language. And there's these other technologies like Codex, which translates natural language to code. So that powers GitHub Copilot, which is really good and proficient in doing programming languages, which is a descendant of the GPT-3 model. And DALL-E, which was created for original and realistic art just from a text description. And ChatGPT itself, which interacts in a conversational way and allows for follow-up questions that hold context. So that kind of leads us to a bunch of use cases that people use. So from summarization, conversational AI, writing assistants, there's just so many cases for AI. And that kind of leads to all these companies and all these people like joining the hype and trying to create their own technology using all these as the backbone. So I guess like speaking to the AI use cases, I'll just go into my own experiences and I'll talk about like how I've used some of these technologies
Yes,
in
please.
industry.
That's great, Aymaan. It's great that you have that practical background as well as the academic. So we can start with the academic. That's where my brother went to school, by the way. So I don't like Dartmouth, but
Oh, cool.
go ahead.
Yeah. So I'll be talking about three of my experiences. I have a little bit more on the medical side at Dartmouth College, and then I have more on the networking side at Verizon, and then I guess a little bit more on the fairness side at MIT. So I'll start with Dartmouth. So I'm currently working on a machine learning project where I'm kind of clustering pixels to identify regions of interest in destructive assays. So I'm kind of profiling several series of sections. So I'm applying a model to specify data such as metals in these 100 channel images. And basically, it's going to help in identifying visual patterns in complex biological images. So I'm using an AI that's called a graph convolutional neural network to analyze and interpret that data. So in that second image, you can see that I'm kind of passing in this input, and there's going to be multiple hidden layers where you kind of define a little change and you kind of train the model to be able to identify these clusters of these metals to be able to see how in these tissue cells to enable same section profiling. So that kind of allows you to detect regions of interest in different types of tissue cells. So that can be pretty useful if you want to apply this type of technology towards detecting cancer or different types of medical aspects. So my specific topic is I'm looking for metals. So that's kind of what I'm doing at Dartmouth. Let me switch over to Verizon. So I have a lot cooler images, but I don't think I'm allowed to show them because I'm currently working there right now. But I have this basic image, and basically Verizon has these large amounts of one fiber assets that are tuned to hundreds of millions of dollars in aggregate. So basically Verizon has all these cell towers across the country.
Yep.
And I'm a little bit of a Verizon fanboy because I use it myself, but basically they have a lot of incomplete fiber that exists in various states. And I'm kind of looking at the financial benefits of opportunities for the view of payoffs. So Verizon has these towers, and I'm trying to see where the most optimum placement is for their nearest cell towers. So if they have a few cell towers in Seattle and there's an area that doesn't have a cell tower, I'm identifying using machine learning and geospatial data to see where they should place the next tower to get the most bang for their buck. So I did this by just taking their own data sets. I'm converting them to data frames, and I'm converting them to a projected CRS. So if you look in that second image, that's not an image from my project, but just an example where I'm using geospatial data about the one fiber plans to just identify like those areas where there are cell towers and where you could connect the nearest fiber to allow for more 5G connectivity in different areas. And I'm able to identify the most valuable fiber to complete in a holistic view. And I created a map where you could see across the United States all the cell towers and the best areas to place new ones. So for Verizon as a whole, they would be able to use this type of analysis to aid in their business where they could place new cell towers and just identify areas where they should place cell towers. Yeah, and then I'll shift over to what I was doing at MIT. So I worked alongside the MIT IBM Watson AI Lab in Cambridge, and my project talked about algorithmic fairness. So let let me talk about what is algorithmic fairness. And basically, it's just understanding and correcting biases. So that includes race, income, sex, gender, and it kind of studies like the methods for understanding and detecting and just mitigating biases in ML and AI systems. Because there's this type of big problem where you kind of have bad data or biased data, and that can kind of affect different types of AI models. So if you look at the second example I have over there with the bikes and skyscrapers. So in 2015, a software engineer found that an image classifier used by Google Photos was labeling people of color as gorillas. And that's a pretty big problem because these types of classification algorithms can be biased. So if you were doing like a resume screen, for example, if you had biased information like certain locations or if the person had a disability, just by using data from people with those types of issues, it might bias it and make those candidates less desirable, even though they might be a perfectly qualified candidate. And that's a problem that is continuing to arise just from having dirty data and biased data. So this example that I have, like just at the top where the individual fairness is, so you can kind of see that that Ryan, whose race was predicted as Caucasian, had a higher score, and Tyree, who is predicted as African American, had a lower score. So this sentiment analysis kind of shows that Ryan would be a better candidate just based on the data. But that's obviously not true. So correcting these sort of biases is a big and important problem. So my project was basically using IBM's infairness library, which is something they created on their own, which was to create a demonstration of fairness applied on a real data set to just evaluate and compare the effectiveness of different fairness interventions on parametric learnings. So I guess the impact of this is just that it kind of promotes just the practice of evaluating the ethical implications of machine learning and just making sure that algorithms can kind of get better and focus on those biases. So we use supervised learning, and basically we use the folk tables data set to just go ahead and training two models with the sex variable flipped, which had original and not original. So that kind of if we didn't use IBM's library, it would kind of have that bias. But by using IBM's library, we were able to have fair models. And we were able to kind of see that finding variables that are kind of correlated with those protected traits rather than the traits themselves. So blindness wouldn't necessarily be ideal. So correcting these biases is a really important problem. And I think that working on this type of research is pretty beneficial and useful. So
of course,
yeah, I guess I know I've been talking a lot, so I'll just leave it for Q&A if you have any questions.
Yeah, I think that again, from a sort of layman's perspective, the ethical questions around AI are huge, and I'm just wondering if it's possible to create these models that are so this is like sci-fi, but are so well constructed that they can actually defeat an attempt to prevent them from showing bias or doing those sorts of things that that we don't want in society. I mean, can you actually build ethics into a model, or are the models so smart that they can just make ethics irrelevant? And that's for both of you.
Yeah.
Yeah.
Yeah, I can just say quickly, and before we start, I want to say, Aymaan, bravo. Just really blown away by all the work that you're doing and just your knowledge of it. So, it just makes me proud. But, I can maybe take a fraction of 1% of credit just for, working with you, but just amazing. So I want to say that, off the bat. So I think maybe to answer Jim's questions, I think the companies that really do care about this should actually hire people that are ethicists that look at this. So it's a little bit difficult because I think finding someone that's an ethicist and knows code could be a little bit hard. But I think they can at least certainly look at the products and see what they do and test them and things like that. So I think there are actual people that do that. I attended a conference where someone did talk about that with self-driving cars, and there's a link that I gave on what are the different scenarios by which a car would behave if uh, there was a potential accident. Like, do you give more weight to saving the driver and passengers or the pedestrians that might be in the way of the car? So I don't even know how to begin to understand how that would be coded. So that's just like one example that I can think of off the top of my head. But to me, I think that needs to be a really important thing that should happen. And I think I had mentioned the Coded Bias documentary. Aymaan had mentioned the work that he had been doing. So I think kind of having a variety of people looking at that, and then actual people that are experts in ethics and philosophy and whatnot, looking at this, I think companies really need to be doing it. Now, whether they are or not, I don't really know a lot about that, but I do know that there are people that are paying close attention to that. So hopefully that maybe assuages some fears, but then at the same time, a lot of this is happening so fast. And I think usually the thing that companies are doing is like, well, how do we make a lot of money with this? And not think so much about like, okay, what are the guardrails we need to look at, ethics, etc. So, and Aymaan, I don't know if you have more to say about that.
Yeah, I completely agree with Mr. Wong, where just creating those AI models that are designed to just minimize bias it's a pretty complex and ongoing area of research. And I know a lot of companies are like trying to work on that. Hiring ethicists is just a really big thing. And I think companies like, I know IBM has an AI Fairness 360. So that's one of the products where it's an open source toolkit and basically it's just made to detect and mitigate bias in AI models.
Sure.
So I think just achieving that like as a whole is something that kind of requires like a concentrated effort across a lot of different dimensions of AI development. And it's something that I think almost all the big companies and even small ones are just focusing and working towards, just to ensure that AI systems are fair. And yeah, I think that, but just by like helping people understand and just learn about the different biases in AI kind of gives them a little bit more depth and understanding.
Yeah, it's amazing. I'm wondering how much, since I'm based in the sort of stock market arena where when I worked for big investment banks, we never had ethicists. I can tell you that. I did know some people who went to jail, but that was, not related to what I was doing. But
Good to hear.
yeah, I think it's important. I'm imagining someone like you, Aymaan, must get a bunch of hits on your LinkedIn profile or however people do it this way these days. And like, we'd like to hire you. If they don't, they're nuts, by the way. But I'm just wondering, where would you find an ethicist? I mean, you are so deep in this, and you're working on these projects. Is there anybody there to tap you on the shoulder, or do they just say go 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 because that's capitalism?
Yeah, that's a good question. I guess for me, just because I'm just a senior studying computer science in college, I've usually I don't think I've been working on any evil AI per se, but
Not yet.
I think for a lot of AI projects, like for it to get funded, I think you kind of have to justify like your reasoning and its purpose. So I know like research I'm doing at Dartmouth, it's heavily funded just because that's kind of helping progress the field of medicine. And even at Verizon, like I don't think cell tower placements is really going to be that evil. And same with MIT, like where their research is fully focused on making this kind of fair AI. But in terms of ethicists, I think I'm not at that level where I'm working on this like deep, like it's going to take over the world type of AI. But if you are, I think definitely like people with a really deep understanding with maybe like a PhD or a master's where they kind of understand computer science as a whole and just how training these types of data sets needs to be done in a very fair and very, very with a good scope on just what you're doing. But I think that's a good question to ask about ethics.
Yep, I think that's, and unfortunately, we are out of time. So I will leave it on that big picture question. But thank you very much, Aymaan Shaikh. Thank you, LeRoy Wong, my old friend, for helping out, and also for all the links that LeRoy has posted as well. So please check those out.
Definitely. And I put some in the chat because I know there's like a lot of terminology with this. And if it's something you don't really work with on a daily basis, it's a bunch of acronyms and, terminology. So, it's something we can go back and look at. So
that's awesome.
You're welcome.
Mind blown, which was the object. Thanks again, both of you, for being so generous with your time.
Thank you, Jim. And thanks again, Aymaan.
Thanks for having us.
Yeah. Thank you.
Bye-bye.
Bye.